Okay, now the stationary wave in open pipe. Already we discussed about the stationary wave produced in closed pipe and also a string tied at the both ends. Now, what are the stationary wave in open pipe? Already we discussed about the definition of the open pipe. The pipe which is open at the both ends, that is known as the open pipe. Both ends are open. Therefore, the point at the both ends has the maximum amplitude. Therefore, both ends is act as a antinode. Both ends is act as a antinode. Therefore, in open pipe, the antinodes are produced at the both ends. In open pipe, antinodes are produced at both open ends. The distance between the consecutive antinodes are produced at distance lambda by 2, lambda 3, lambda by 2. Because already we discussed in stationary wave, the distance between the two consecutive antinodes is lambda by 2. Therefore, the antinodes produced in an open pipe, right, is a distance. The consecutive antinodes are produced at distance lambda by 2, lambda 3, lambda by 2, and so on. N lambda by 2. Right? If the wavelength is lambda of a stationary wave in open pipe of length L, right? Therefore, the length of a pipe or the wavelength of the stationary wave producing open pipe is, if wavelength of wavelength is lambda for open pipe of length L, right, of length L, then the stationary wave will only produce, then stationary wave only produce in length L is equal to, if L is equal to in lambda by, then this condition, the stationary wave produced of wavelength lambda in open pipe of length L. Here the condition is that the length L is equal to in lambda by 2. Right? There is our equation 1. Here n is equal to 1, 2, 3, and so on. Lambda is equal to wavelength, and L is the length of a column in open pipe. L is equal to length of a column in open pipe. Therefore, the wavelength of stationary wave in open pipe is lambda n is equal to 12 upon n. 12 upon n. There is a second equation. And the frequency of the stationary wave in open pipe and frequency of stationary wave in open pipe is Fn is equal to Nv upon 2n. Equation number 3. Right? Here where n is equal to 1, 2, 3 and so on. Where n is equal to 1, 2, 3 and so on. Here this again. In open pipe, the antinodes are obtained at both open ends. Therefore, the consecutive antinodes are produced at distances lambda by 2, lambda, 3 lambda by 2, and last of nth antinodes n lambda by 2 distance. If the wavelength is lambda for open pipe of length n, then the stationary waves are produced. In this condition, if the length L of a column in open pipe is equal to n lambda by 2. Here the n is equal to 1, 2, 3 and so on. Lambda is the wavelength and L is the length of an A column in open pipe. The wavelength of stationary wave in open pipe is lambda n is equal to L upon n. And frequency of the stationary wave in open pipe is Fn is equal to Nv upon 2L. Okay, now listen here. These all equations are similar as already we obtained the equation of frequency, wavelength and length of a string. The stationary waves produced in a string tied at the both ends. That is the similar situation. Right? In string, the both ends are tied with the rigid support. That means at the both ends, the nodes are produced. While in open pipe, here the both ends are open, therefore at both ends, the antinodes are produced. Right? Therefore, now taking n is equal to 1. Taking n is equal to 1. Frequency of harmonic or the mode of oscillation is F1 is equal to V upon 2L. Now length L is equal to lambda by 2 and wavelength lambda 1 is equal to 2L are obtained. Therefore, the stationary wave in open pipe are obtained like this way. There is the length of open pipe, there is the x is equal to 0 and there is the x is equal to L point. At the both ends, antinodes are produced. So that point is antinodes, there is also antinodes A and E. Now here in L length, lambda by 2, wavelength must be produced. Therefore, we can do the diagram like this way. That is the nodes. So at the both ends, the antinodes are produced while this point is the node point. So that is the first one, the fundamental harmony. First one, fundamental harmony. So by taking the n is equal to 1, frequency of harmonic F1 is equal to V upon 2L, L is equal to lambda by 2 and F1, the lambda 1 is 2L. So F1 is called first harmony, first or fundamental harmony. Now taking n is equal to 2. Taking n is equal to 2. What's happened? N is equal to 2, F2 is equal to 2V upon 2L. That means the 2F1. Length L is equal to 2 lambda by 2. That means the lambda. 2 lambda by 2. That means the lambda. And frequency and wavelength lambda 2 is equal to, in this equation, 12 upon 2. That means the R octave. R octave. Here, by taking the n is equal to 2, we obtain the F2 is equal to twice F1. That means the second harmonic or the second mode of oscillation is obtained. Now, what is the diagram or what is the stationary wave when the A column in open pipe oscillate with the second harmonic? So there is the x is equal to L and there is the x is equal to 0. So here there is the NT nodes. There is also the NT node. Right? So here the one nodes and also the one NT nodes are generated like this. So at the end, the NT nodes are generated. So these two are the node points. Here also the NT nodes. So there is the second harmonic for the first overtone. Is the second harmonic. F2 is called second harmonic or first overtone. First overtone. Overtone is always less by 1 than the number of harmonic. In case of string and also in case of an open pipe. Now, taking n is equal to 3. Therefore, F3 is equal to 3V upon 12. That means the 3F1. L is equal to 3 lambda by 2. L is equal to 3 lambda by 2. And lambda 3. Wavelength of third harmonic is 2L by 3 R octave. So in L length, one complete wave and second half wave are generated. One complete wave and second is the half wave are generated. So F3 is called the third harmonic because the frequency of this harmonic is 3 times of the fundamental or the first harmonic. So as we do the situation or the stationary wave in a column of open pipe. So there is the x is equal to n, there is the x is equal to 0. Right? So how we do the stationary wave? For that purpose, first the NT nodes are at both open end. After that, the node points on both sides. Again the NT nodes, again the NT nodes, and the nodes. Right? Therefore, there is the open, like to this way. Just a minute. That must be open. That means the intinodes must be created here. Like this way. Okay. Now listen here. Just a minute. There is the x is equal to 0. There is the x is equal to n. Therefore, there is the antinodes, and there is the also antinode. Like to this way. So these are the antinodes, this and this. So there is also antinodes, and that is the node points. So there is the third harmonic. So F3 is called the third harmonic or the second overtone. Or second overtone. Thus, by taking n is equal to 4, 5, 6 and so on. Fourth, fifth, and more harmonics are obtained. And corresponding n minus 1 overtones are obtained. Thus, all harmonics are possible. Thus, all harmonics are possible. Clear this thing? So that is in case of a open pipe. Clear this thing? Okay. Now listen, again we repeat it. What is the situation in open pipe? Just we discussed that the open pipe is the open at the both end, therefore the antinodes are obtained at the both end. We know that the distance between the two consecutive antinodes is lambda by 2. Right? Therefore, in open pipe, antinodes are produced at the both open end. The conjugative antinodes are produced at distances either lambda by 2 or lambda or 3 lambda by 2 and so on in lambda by 2 distances. If the wavelength is lambda for open pipe of length L, then the stationary waves are produced. For L is equal to n lambda by 2, where the n is equal to 1, 2, 3 and so on. Lambda is equal to wavelength and L is equal to length of an A column in open pipe. The wavelength of stationary wave in open pipe is lambda n is equal to 2L upon n. And the frequency of the stationary wave in open pipe is obtained directly. Fn is equal to Nv upon 2L. Actually, that is obtained from this equation. We know that V is equal to F lambda. Therefore, lambda is equal to V upon F. Substitute the value of F. Sorry, here the F is equal to V upon lambda. Substitute the value of lambda here. So we directly obtain the equation of the frequency Fn is equal to Nv upon 2L. Right? Okay. Now, let's take the n is equal to 1. The frequency of harmonic F1 is equal to V upon 12. L is obtained the lambda by 2 and also lambda 1 is equal to 12. That means in given length of an open A column or an open pipe, here the lambda by 2 stationary wave with lambda by 2 wavelength is generated. That means the half wave is generated. But here condition is that both ends of open pipe the antinode must be K. Therefore, this type of the stationary waves are generated when the A column is oscillating with the fundamental frequency or the first harmonic. So there is the first harmonic or the fundamental harmonic. The frequency F1 is equal to V upon 2. Now, F1 is called the first or the fundamental harmonic. Now, taking the n is equal to 2, we obtain the F2 is equal to 2V upon 2L, that means the 2 times F1. That means the second harmonic is formed. Now, L is equal to 2 lambda upon 2, 2 cancel, therefore in L length 1 wave is formed. And the wavelength lambda 2 is equal to 2L upon 2, 2 cancel L. R of A. F2 is known as the second harmonic or that is known as the first overtone. Now, the stationary wave produced in A column of open pipe in such a way that the both ends, the antinode must be K. Therefore, that is the situation of the antinodes produced in the A column of an open pipe when it oscillates with the second harmonic. Now, taking the n is equal to 3, F3 is equal to 3V upon 2L, that means the 3F1. Length L is equal to 3 lambda by 2, lambda 3 is equal to 2L by 3 out of 10. F3 is called third harmonic or the second overtone and situation in the A column, that means the stationary wave in A column is like this. Okay. Thus, by taking the n is equal to different value 4, 5, 6 and so on, the 4th, 5th and more harmonics are obtained and corresponding n minus 1 overtones are obtained. Thus, all harmonics are possible in open pipe. Clear this? So, just we discussed about the harmonic produced in string tied at the both end, closed pipe and also the open pipe. What are the harmonic produced in the string and open pipe? The equations are same but the pattern are different. Because in a string, at the both ends are tied, therefore the notes are produced. While in open pipe, both ends are open, therefore the antinodes are produced. Equations are same but the figure are different. While in case of a closed pipe, only the odd harmonics are possible, even are not possible. Clear this thing? That is the main difference between these three medium in which the mode of oscillation or the harmonic of oscillation we discuss.